Alright, so we are going to. Hello everyone, my name is Vipin Yadav and you're watching Mathematica Brainy. So today we are going to continue with our chapter, that is complex number. In the previous lecture, we had done some properties that are applicable, or you can say we learned how to add, subtract, multiply, and divide to complex numbers. Today we are going to understand one concept of I, and that is power of I. Now this I is known as iota. It is called as iota. Okay, fine. Now this symbol is actually used to represent the imaginary part. Now we know that I is actually, it has been given a this is the symbol which has been given to this particular value minus of 1. Alright. Now what we, if I do, if I put the square of it, if I find out the square of this, let's say, so I'm squaring on both the sides, what we get? We get I square is equals to minus 1. So this you need to understand, you need to remember. So I square is always minus 1. Fine, I square, because this is going to be very helpful in solving some questions based on power of I. So just we are understanding how this we have to simplify this power of I. So I square is minus 1. Let's say I have I cube now. I cube. Now I have to simplify this. I have to simplify this. It means I have to write this in terms of either I or some particular value. Fine. Now here I can write this I as, can I write this as I square dot I1? We know that this formula of a, you must have studied in complex number, a to the power m into a to the power n equals to a to the power m plus n. So I have just used this formula. Why? See here. Can I write this I cube as I2 plus 1? We can write this. Alright, using this same formula, we can write this I to the power 2 into, now how do we indicate this into in complex number? With the help of dot, into I to the power 1. So here we can say that I cube will be equal to what? I square dot I. Now I square, I know what is the value of I square, it's minus 1. So we can directly write, or you can say we can write this I cube as minus I. Yes, we can write this I cube as minus I. Fine. So whatever the power of I is there, we are just trying to represent that that thing in terms of either I or some value. Fine. Now let's say I have I to the power 4 now. I to the power 4. So you know that this I to the power 4 can be written, because I know the value of I square. So can I write this I to the power 4 as I square to the power 2? Yeah. Anyhow I have to bring I square. Anyhow. So you have to break this power in such a manner that you get I square in the innermost. Okay. Similar, just try to see here. I to the power 4. Now I have to bring I square, and outside the power can be anything. Alright. So now I know the value of I square as minus 1. So I to the power 4 will be what? Minus 1 to the power 2. In place of I square I put minus 1. So this will turn out to be 1. So I to the power 4 is actually what? It is 1. We can see what is the value of I to the power 5. So now these three things you need to understand. Let me write this I to the power 4 equals to 1. This also you need to remember. Alright. So these two will be very helpful. And one more we found out, I cube. So what was I cube? I cube was minus I. I cube was minus I. So these three things you need to understand. I is already I there. Nothing, no value, no extra value or no some other value is there. I square will be represented as minus 1. I cube we found out it is minus I. And I to the power 4 is what? 1. Now if I give you any value, any number, or you can say any complex number. Let's say I is there and the power is, let's say, 42. Power is 42. So now I have to break this power of 42 in terms of 4, because I to the power 4 is what? 1. So I have to just break this 42. Okay. Now this 42 does not come in the power of or in the table of 4, but what we can say, can I write this 42 as I 4 times 10 plus 2? We can write this 42 as 4 times 10 plus 2. We have to represent the power in terms of multiples of 4 plus some extra power. Depends on this power. So I know that this will be what? I to the power 4 to the power 10 dot I to the power 2. If the concept of exponents is clear, then you would understand it. तो यहाँ पे इसको अब ये मैंने ऐसे क्यों लिखा? See how I have written this, am into n, so it will be what? am to the power n. ये वाला फॉर्म हमने यहाँ यूज़ किया है और ये वाला फॉर्म मैंने आपको पहले बता दिया है, ठीक है? So now see here, I to the power 4 we know it's 1. It is 1. 1 to the power 10 dot I square is what? Minus 1. Minus 1. So I to the power n, I to the power 10. Now if you have any power on I, if you have any power on 1, the answer will be 1 always. So I to the power 10 will give you 1 into minus 1. So 1 into minus 1 will give you minus 1. So we can write this as I to the power 42 equals to actually minus 1. So this is the way to solve. Alright, let's take another example, and since we know now what we have to do, we have to solve it fast. Alright. Okay, now we have these 4 parts and I have to simplify this. I have to simplify it. So let's begin with this. First one, what can I write? I have to express this power 50. I have to break this power 50 in terms of multiples of 4 plus some extra power. Okay. So this 50, how you are going to do this? If you don't know the mental way, or you can say if you cannot do directly, what you can do, you can just divide this power by 4. Alright. So it will be how much? This much is clear now. So this 50 can be represented as, 50 is what actually? Quotient into divisor plus remainder. Alright. So I50 can be written as I4 into 12. 4 into 12 will be 48 plus 2. Fine. Now I can write this as I4 to the power 12 into I square. Alright. So I know I to the power 4 is what? 1. So 1 to the power 12, that will be 1 only. I square is what? Minus 1. So it will be minus 1. So I to the power 50 is what? Minus 1. Fine. Let's do this one. Now how will you break this 243? So when you divide by this 243 by 4, you will get something like this. It will be I to the power 4 into, can we say it is as 60? That will be 240 plus 3. Alright. Now this can be written as I to the power 4 to the power 60 dot I cube. Now I to the power 4 is what? 1. Alright. So 1 to the power 60 dot I cube. Now I have told you I cube. What is the value of I cube? Minus I. We have found out minus I. So now 1 to the power 60 will be 1 only. 1 into minus I will give you minus I. So I to the power 243 is actually minus I. So this also we have done. Let's come to the next one. I to the power 60. So I to the power 60 is what? 60 can be represented as a multiple of 4. Alright. So 60 is what? 4 into 15. Alright. So this can be written as I to the power 4 whole to the power 15. I to the power 4 is what? 1 in to the power 15. That will be 1. So I to the power 60 is what? 1. Right? Let's do this one. I 1 to the to the power 123. So now how will you break this? It will be we can say this as 4 into 30, so that will be 120 plus 3, so 123. So I can write this as a I to the power 4 to the power 30 dot I cube. So I to the power 4 is 1, so 1 to the power 30 is 1 only, into I cube is what? Minus I. So answer is minus I. So I hope you have understood how to simplify. If any power is given for that I, you have to simplify. It means you have to write that whole thing either in 1 or minus 1 or I or minus I. All right. If some extra power is there, you have to reduce it to these four quantities. Whatever is coming, that will be solved. Okay. So I hope you have understood how to simplify the power actually. So let's recapitulate. What do you have to remember? I square is minus 1, I cube is minus I, and I to the power 4 is 1. So whatever power you are going to get, you are going to express that power in terms of or in multiples of 4 plus some remainder. Okay, if there is. I hope it is clear. Fine. Now next is modulus of a complex number. See, modulus of a complex number is actually the positive number, or you can say positive quantity. So how we are going to represent this modulus of a complex number? Let's see, and how we are going to find it out. So here, let's say I have taken one complex number z as a plus ib. Now, if you want to represent mathematically what is this this modulus of z will be, you will make two straight lines and between them you have to write this. So this will show, or this will say, the modulus of complex number z. So it will be given by this formula, root of a square plus b square. Very simple. It is modulus of any complex number is denoted by this, and the formula is this thing. So let's solve one question. Z3 plus 2i. So modulus of this z will be what? Root of 3 square. A is what? 3. So 3 square plus b is what? B is what? 2. 2 square. So it will be how much? 9 plus 4 means root 13. So modulus of z, which is 3, z is what? 3 plus 2i. The modulus of this complex number is what? Root 13. Modulus will never be negative. It will always be positive. Okay. Now we have one more here, conjugate. Since we have told you in the previous one, so let's do it again here. To find out conjugate of any complex number, whatever sign is there in front of b, or in front of I, that sign only has to be changed. No other sign has to be changed. So if I ask you, what is the conjugate of, let's say this one, this z equals to a plus ib. So very simple. You don't have to do anything. You have to just change the sign which is in front of I. So conjugate of z equals to, z is this. So you have to just change the sign which is in front of I. Now in front of I is what? Positive. So you have to just change that sign positive into negative. Write this. So this is the conjugate of z. Okay. Similarly, if I have, let's say, z1 is minus 4 minus 3i. Let's say this is your z1. So conjugate of this z1. Now how we are going to represent the conjugate? We are going to represent the conjugate by this symbol. Just see here. This is the complex number. We have to just put the bar over this. So that will be the conjugate of z. So if I say this, if I say z bar, what it will be? The conjugate of z. And what will be the conjugate? Just change the sign which is in front of I. So conjugate of z will be what? A minus ib. All right, a minus ib. So what we can say, conjugate of z can be represented by this symbol. Okay. Now, what is the conjugate of this one? Z1. So symbol, how to represent conjugate? Put a bar, that's it. Change the sign which is in front of I. Okay. Rest all the sign will remain same. So this is the conjugate of Z1. Okay. Now there is a relationship between the conjugate, modulus and the complex number. So modulus I know, conjugate also I have told you, and there is a relationship between the conjugate, modulus and the multiplicative inverse. When I told you about how to divide a complex number by another complex number, then I told you about the multiplicative inverse of any complex number. So what is that? Just try to understand here. Let's say I'm talking about this only, fine. Let's take this one, a plus ib. I'm just going to talk about. So now this is your number, complex number. Conjugate is what? A minus ib. I have already told you. Conjugate is this. Modulus of z is what? Root of a square plus b square. Fine. Now multiplicative inverse of this set. Inverse of z. As I told you, it is actually the real part upon root of a square plus b square. This z only I am considering. This will be what? Plus I minus b upon root of a square plus b square. If I join them, it can be written as root of a square plus b square. LCM will be here, root of a square plus b square. It can be written as a. So this will be what? Plus into minus, minus ib. And this is multiplicative inverse of z. Okay, multiplicative inverse of z. So now what we can say, can I say that, so this will be what actually, how do we represent multiplicative inverse of z? It can be represented by z to the power minus 1. Why? Because multiplicative inverse of, let's say 2. What is the multiplicative inverse of 2? 1 by 2. So what is the multiplicative inverse of z? It will be 1 by z. 1 by z is what? Z to the power minus 1. Fine. Or you can simply write 1 by z. That's it. Multiplicative inverse of z is 1 by z. Now this, how can we write this? A minus ib. Can we say this as conjugate of z? Upon, how can we write this? A square, root of a square plus b square. Root of a square plus b square is what? Mod of z. So if I want to, let's say this is your mod of root mod of z. All right. Now mod of z. So if I want to express this, so it was a square. All right, my mistake. Root of a square plus b square. So now see, root of a square plus b square is what? Mod of z. But here I have a square plus b square. It means I have to find out the square of this thing. So ultimately we have to find out the square of this mod. So we can say mod of z whole square. Okay. So now we can shift this. This can be given above on the left hand side, and this z will go and get multiplied. So z into z conjugate. So this is the very important relationship that you have. All right, I hope it is understood. So I have explained modulus, I have explained multiplicative inverse, and I have explained conjugate. So these three things, they are correlated with this. All right, mod of z square of mod z equals to product of complex number and its conjugate. So this you need to remember. In the next class we are just going to solve some questions regarding this. All right. Thank you so much and keep watching my videos. Thank you.